Hey, welcome everybody to Bisq Tech session number 3 on Bisq's trade protocol. If this is the first tech session that you're seeing, we've done a series of these so far. The first, sorry, one moment. Sorry guys, I have a technical issue here. I have a pretty bad echo happening. Hopefully it's gone now. Okay, let's try that again. So actually, no, sorry, this is still showing up for me. I can't avoid hearing myself.
So I'm muted. Christoph, are you muted as well?
I'm muted as well, yeah.
I think I have a separate window open. 1 second. Okay, well, maybe we'll cut that out in post. But anyway, let's try that again. So this is our third tech session. We've been doing a series of these over the last few weeks. If you've missed them, you can go back to the beginning. We have a new playlist here on YouTube where you can catch up. The playlist is named Tech Sessions, so you can go check that out. The first one is a broad technical overview of all things Bisq, and it's a great place to start. And the last one that we did is on the peer-to-peer network, Bisq's own bespoke peer-to-peer network on top of Tor. And now we take it up one level this week, and we talk about the trading protocol that's implemented on top of that peer-to-peer network, how Bisq clients talk to each other, orchestrate with each other to complete the process of buying and selling Bitcoin for fiat, or Bitcoin for other cryptocurrencies. So if you're interested in seeing really how does Bisq work under the hood, how do we implement non-custodial, truly peer-to-peer trading, and this is where it starts to get right into the meat of that. So I'm going to hand this over to Manfred now, and he'll walk through a series of slides going into detail on all of this. And if we have time, we might even see some live coding and some hands-on kind of stuff toward the end. So Manfred, take it away. Thanks.
Yes, thank you, Chris, for the introduction. I start my screen sharing. I hope it's visible now. Yeah. Yeah, welcome to the third tech session, and we are covering this time another very important area of the Bisq network protocol framework, whatever. That's the trade protocol. Yeah, the agenda of today is to give an overview. I will start with a graphical overview about the trade protocol so that everybody's on the same page. Then we talk about the main task, what the trade protocol is achieving. And then we look into the protocol implementation, how it's implemented in code. We look a little bit into this task runner framework, which is a part of the implementation. And then we'll show the main classes of the protocol to see a little bit how it really looks like. And then we're open for questions and answers. And of course, if you have a burning question, just interrupt me and I will try to answer it. Okay, most of you who have seen who have read the white paper will have seen this high-level graphical overview. So just we'll go very quickly over it. So to see, and we can extract from here also the main tasks, what you want to achieve in the protocol. Sorry. So we have Alice as Bitcoin buyer and Bob as Bitcoin seller. Alice has created an offer. We are not talking, or we are not covering this process, how to publish an offer and so on. That's not part of the real trade. The real trade happens when Bob is taking the offer from Alice. And yeah, we see here with this blue line that Bob is sending some message to Alice. It's basically the intent to take the offer. He's sending some initial data. He's doing his trade fee payment. Alice is doing some verification. They exchange the data, what they need to do for creating together the multisig or the deposit transaction. So in this in this transaction where they are locking in their security deposit and the Bitcoin seller, the Bitcoin amount, what he wants to sell, yeah, they create together a transaction. And because they're not on one place, So they have to exchange in several parts, several information, so that they're able to sign the transaction. As soon as this is done, as soon as the transaction is published, Alice has to wait for at least one blockchain confirmation, and then she has to do the manual step to make the fiat transfer, or when she's doing when it's an altcoin trade, do the altcoin transfer. After she has done this on her online banking webpage, she clicks a button in the application and confirms that she has started the payment. So here we have a notification where she's just notifying the other trader, Bob, that she has done a very important part of the trade protocol. Beside this sending of the notification, I've done the payment. She's also already sending the signature of the payout transaction. I will explain a little bit later why and so, but with that we are avoiding an extra step in the communication. Then Bob sees this notification. He will check his bank account, and as soon as he has received the money, he will create the payout transaction, and that's why Alice was already sending before the signature. She cannot lose anything. She wants the Bitcoin money out, so she has nothing to. She has no risk to sign already her part of the payout transaction. So they're using the money which was locked in the multisig and make then the transaction, as we see here at the end, with 1 Bitcoin plus the security deposit to Alice side and the security. And Bob, as he has received the money, he is now also okay and willing to release 1 Bitcoin to Alice side. So he'll take the signature from Alice, put it into the transaction and signs his part, and then publish the transaction and send then a notification message to Alice that the transaction has been published and everything is complete. We have also a more detailed overview. I don't want to go through all the steps here, partly because it's not 100% up to date, and I think it's a little bit too much overview, but you see here already under the hood, it's more complex. Like in this overview, we have just the most important part, but all the details, how many messages are sent back and forth between the users to ensure that everything is safe. That's not covered here. That's much more covered here, also not in perfect detail. And as I said, I think it's outdated. There has been some changes which have not been applied to this overview, so I don't want to go into the details, just to give an impression that there happens a little bit more. So as we said already, the main task is to create this multisig, also the deposit transaction, where both users are putting in their security deposit and the Bitcoin seller the amount what he wants to sell into this multisig transaction. So the money is locked in there, nobody can spend it as long as both traders are not providing a signature to unlock this money in the payout transaction at the end. Then they need to exchange the payment account data, like for a fiat payment, the bank account number and all the data what Alice needs to make the fiat transfer to Bob, or in case of altcoin, it's just altcoin address. Then they need to notify each other when they did some user actions, like signaling that Alice has sent the fiat money to Bob, and that Bob has received the fiat money and has done the payout transaction. And of course, the creation of the payout transaction. We have basically the main, so on a very high level, we have only two roles, a buyer and a seller, and they have different responsibility and different flavor in what they're doing. When you look a little bit closer, there are more differences when the buyer is the taker or when the buyer is just the maker, also who has created the offer. There are some differences, not too much, but differences enough to really separate these roles. Sorry. So all in all, we have two different trade pairs, that the buyer is the maker and trades with the seller, which is the taker, or that the seller is the maker and the buyer is the taker, which results all in all in 4 different roles. So every Every trader can be either in the buyer as maker, or the seller as taker, or seller as maker, or buyer as taker, depending if he's buying or selling Bitcoin, or if he's taking or creating the offer. And these 4 different roles are designed in 4 different protocol classes. They're called seller as maker protocol, seller as taker protocol, buyer as maker, and buyer as taker protocol. Each, and these protocol classes, they contain a list of tasks which get executed in a certain area, and those tasks are, every unit of work, every logical unit is encapsulated in a task. Like, for instance, verifying that the other peer is not banned, or that he has done the trade fee payment, or publishing a transaction. Every such an action is a task, and it's encapsulated in one class, and the execution of one task after the other, it's executed in sequence, is done in a task runner class. It has nothing to do with the JavaFX concurrent task. We are here in single-threaded environment. It's all on the UI thread. Here is no need for having extra threads. So it has the term task is a little bit unfortunate, because it's overloaded with usually tasks are used in a threaded context. If anybody come up with a better name, we can rename this, but I didn't find a better name when I designed it. And this task runner framework is, I've written it by myself. There might be some existing frameworks out which would have done exactly what I needed, but at that time I didn't find one, and it was actually not really complicated. It's basically a list of tasks defined as classes, which you're adding here, and you can basically, when you read this list of tasks, you're reading all the steps what you have to do in that area. The trade protocol consists, we will see a little bit later in the code, consists of different areas. Like, first, getting in touch with the other trader and signal that you want to take their offer in Bob's side, and then signaling that the fiat payment has started. And all those areas are handled by one task runner with a collection of different tasks. When all tasks are completed, we get the result handler called. When anything goes wrong, we get the fault. Here we have an example of a single task. That's a very simple one, publish trade statistics. So at the end, after take offer process, when the trade has started, the taker will publish the trade statistics. So he creates this trade statistics object with the data what required, and publish it to the peer-to-peer network, and then calls the complete with that this task gets complete, and the next task, if there is one in the list, gets executed. When anything goes wrong, it calls a failed method, and everything stops here. For exchanging data with the other peer, we are using trade messages. It's like always over Tor hidden services, using our peer-to-peer network. At the take offer process, the other peer has to be online. Later, as soon the deposit transaction has been created, we are supporting also offline peers. Also, when it takes a day until the money has arrived on Bob's side, he don't need to be online all the time. He can go offline. And when Alice has sent the message, I have sent the money, and Bob is not online, the message will be saved in a mailbox message. And when Bob goes online, he will receive this mailbox message from the network, and then execute this message. Everything is as usually we are using our direct messages when both peers are online, and they're encrypted by default. And only in the second part we are also supporting mailbox messages. The reason why it doesn't make sense to support offline peer the take offer processes just because it would take too long. And Alice, when Bob is taking the offer of Alice, Alice will reserve the offer for 1 minute or so. And when Bob would fail for whatever reason in this time, the offer will become available again. But we want to avoid that we have concurrent access to one offer and three traders are taking the offer at the same time, and yeah, Alice could not handle this. So the offer gets reserved, and it's basically taken away from the network for a short period of time. And when the trade really has succeeded in this time, the offer is removed. Otherwise, Alice will reactivate the offer. And with supporting offline peers, that would take way too long, and Alice would have locked up her offer way too long, and so it's not practical. And yeah, all the trade messages, as always, are protobuf encoded. Yeah, the data is mainly encapsulated in the trade object itself. We have also 4 different types of trades: sellers make a trade, sellers take a trade, buyers make and buyers take a trade. They're parallel to the trade protocols. The trades are taking keeping track of the state, not only of the trade state. There are a few different types of states and phases where you are in the protocol. And the trade object knows which protocol it uses. So when it's a sellers maker trade, it will use then the sellers maker protocol. Beside that, the trade contains a process model which handles basically all the data which are not directly fit into the domain of the trade, and also access to other domain objects like other services. And the process model contains a trading peer, and the trading peer contains all the data which is relevant for your other peer, like the onion address from your other peer you are storing in the trading peer. And all those data, because they're all contained in the trade object, the trade gets persisted. So all this state of the current process where we are in the trade protocol gets persisted with the trade. Yeah, let's jump into the code. There is no real documentation about the trade protocol, so the code is the only reference. And I changed my screen sharing, 1 second. Yeah, you should see now. You should see now my my IntelliJ screen. I have here 2 trade protocols open: a seller as taker and a buyer as maker. We could also try the other one, the seller as maker and the buyer as taker, but let's stick with this. And let's start with here we have already the comment start trade. Let's say the taker is taking the offer at this moment. There are a few steps before this happens. That's handled in another area in the offer protocol. So first, the taker is asking if the offer is still available and ask for reserving the offer for a short period of time. That's not handled here.
Sorry, Manfred, could you zoom the window a little bit?
Yeah.
So that the font is bigger, especially if we have viewers on mobile devices.
Sure, yeah. 1 second. Let's see how this looks. It doesn't. There is this zoom. What's the shortcut for zooming the whole window?
You can do Command-Shift-A.
No.
In IDEA, if IDEA is focused, you can do Command-Shift-A.
No, there I have probably different.
Oh, okay.
But
there's an increase font size command if you do it from the.
Okay, increase. That's over there. A few. But on Mac you can scale up a window as well. What's the command for this? I usually never use this from the operating system itself.
Yeah, I don't know. You can also just shrink the size of the window and only show the editor, and that'll
yeah.
There you go. Much better.
Yeah. Let's remove that as well. Is it? Yeah, I think it's more readable now. Huh?
Mm-hmm.
Yeah. Goody. Yeah, we are starting here with take available offer. So we are starting here a task runner. We are adding all the tasks required, and basically you can read here the process. Yeah, first you are verifying the maker account. You are verifying the maker payment, fee payment. You are selecting the arbitrator, the mediator. You create your offer fee, the taker fee transaction. You are creating the inputs for your deposit. So in the next step, the buyer can create already the deposit transaction. He would not be able to sign anything before knowing your input. So you are delivering the data required for the other peer that he can construct a full transaction. And then at the end, that's usually always the last step, that you are sending a trade message to the other peer. And when we are looking into one of those classes, like which one, maybe let's go to this one. Yeah, here we are creating this, as we are preparing all kind of data, what we need for sending this pay deposit request message to the other peer, and we are filling it up, and then we are sending it over the peer-to-peer network. And when we see it in the listener that it has arrived, then we call on complete. When anything goes wrong, it's a failure. And yeah, let's go to the next step. So the buyer is maker, so the peer in this trade. He is listening on incoming messages, and when he receives here this message, pay deposit request, that was what we have sent it here in the last task. Then yeah, this code get executed, starting a task run again with those tasks. So the first task in this case, when you receive a message from the other peer, you're always processing this message. So you are verifying, you're verifying all the data if they are valid, and then you are putting those data from this message to your data model. You're doing all kind of verification. You verify that the arbitration and mediator selection is the same. Mediator is not implemented yet, but it's prepared for the next version of the arbitration system. And here the interesting start, yeah, we're creating a contract. So every trade contains a contract. In the contract, basically all the, let's have a look to this class. Here we're creating the contract, and it contains all the relevant data of the trade. So it's really like a legal contract, basically. All the important data are in there, and because it's part of the deposit transaction, also the hash of the contract will be put into the op return data. And because both are signing this transaction, both are signing the contract as well. So both are agreeing that they agree to this contract, and basically this contract should be really legally valid. It's a question if the courts would really accept it, but basically it should be valid. And yeah, let's go back here. Here is the important task here. We are creating the deposit transaction. So we are going to the trade wallet service, and we are creating the transaction and signing the transaction. Also, yeah, the buyer as maker. I think that's Ali's side. She has received the input for this transaction from Bob and the optional change output for Bob. So she has now all the data. She can take her own inputs and optional change output. Here she has the op return data also. So she creates the full transaction, signs it, and sends it to Bob. It would not be valid yet because it's missing the signature of Bob. That's the next step then on Bob's side. And she's also set up a deposit transaction listener. So in case she would not receive then the message from Bob when Bob has published a transaction, she would still recognize that the deposit transaction has been published because she's listening on the Bitcoin network for this transaction. And as soon as it's published, she's executing the code to go to the next step. And here the last task as well, sending a message to the other peer, putting in the data what's required here, especially the prepared deposit transaction and all kind of other data which is required. And back to Bob's side, he is listening after he has sent the message. He is listening to this publish deposit transaction request, create message. When he has received this, he is executing the next steps. First, again, processing the data, verifying it, and putting it to his data models, doing all kind of verification, especially verifying the contract and signing the contract. And then signing and publishing the deposit transaction. So the deposit transaction has been already completed. So it has been created. It was only missing the signature from his side, and he's doing this in that task and publishing the transaction and sending this message that the deposit transaction has been published to Alice, and as well publish trade status. That's what we have seen in the slides. Alice received then this message. As we said, we have some resilience for errors. So when she would not receive, because of network problem, this message, it would still not fail because this listener would get called and she would have basically all the data. So in this message, there's nothing super relevant. It's just the notification, the transaction has been published. It's usually arriving earlier because it might be that she's only get called the listener when the transaction is in the blockchain. So it can take 10 minutes or more. And this message should usually arrive faster. So she should get earlier notified. And yeah, after this, she has to wait. As the take offer is finished after this step. And she has to wait for one blockchain confirmation. When this has, when one confirmation has been done, she has to start the fiat payment. So that's all handled in the UI. She got this pop-up displayed to make the fiat payment. In the very beginning, Bob is sending the payment account data. We see this in the take offer. 1 second. I think in this message, Bob's payment account data are sent as well. Yeah, here are the payment account data. In this payload is only the relevant data which is required for sending the fiat. There's nothing special which is local to Bob's, like the name of the account or whatever. And where we are, yeah. Back to here. So when Alice when one block confirmation has arrived, she has to start the fiat payment. And when she has done this, she is clicking this button, and this button is triggering this method, this on fiat payment started, and she doing again all kind of checks before sending the message, and then sending this message. And this message contains already the signed payout transaction. Because we said already before, she has nothing to lose anymore on this side. She has done her job basically by sending the fiat money, and she's waiting for her money for the payout. And to avoid that, we need an extra step at the end. She's already sending this signature to the other peer. Bob is listening for, 1 second, we are here. He's listening for this message that Alice has started the fiat payment. And as soon as he receives this, he got a UI notification that he has to check his bank account. And when he has received the money on his bank account, he's clicking then the button, yeah, I've received the money. And with this button click, we are executing this task runner. And here, Bob is signing and finalizing the payout transaction. So he has already received the signature from Alice. So he has everything to create the payout transaction, which uses the output of the multisig transaction, and yeah, making the payouts to Alice's side and pay back the security deposit to Bob's side. He's publishing the payout transaction, and he's sending a message to Alice. Again, we have here this extra security that Alice were setting up a payout transaction listener. In case she would never receive this payout transaction message, she would get notified over the blockchain that she see, okay, there is a payout transaction I was waiting for, so Bob has done everything, otherwise he would not have published this. And there is nothing special happening when Alice receives then the payout transaction published message. She's just processing it and updating the state, and yeah, she's done. So with this, the whole trade between the seller as taker and the buyer as maker is complete. Yeah, I hope this gave a little bit an idea how it's implemented in the code. I mean, all these tasks, of course, contain much more detail, but I think for the goal of this presentation, it doesn't make sense to go deeper. I will go back to the slides, 1 second. Yeah, the trade protocol is a part which were very early developed, of course, and it's pretty stable, so there's not too much open work there. But of course, when we want to add new features, like for instance, automated altcoin trades, so that on the altcoin side, we could basically look up at the altcoin block explorer to see when the transaction has been confirmed on the altcoin block explorer, and then doing these steps, which is done manually, that signaling the sending of the altcoin and confirming the receipt of the altcoin could be done automatically by code. And when we're supporting this new feature, it would require some additions in the trade protocol to handle this. So, of course, when we would have, it has always had room for improvements. Maybe some data can be optimized. I think there cannot be messages removed. I think it's already very optimized. There are not too many messages sent around, and I think you cannot go lower. But yeah, of course, there's always stuff to improve here. I've listed here a few things which are open issues in that area. One thing is that the trade fee is not verified at the moment. So basically, people could cheat here, but it requires quite a lot of engineering knowledge to do this, and probably those people who are able to do this, they don't need to cheat for not paying the very low trade fee. But of course, that's an open task. It requires a little bit of effort because we need to make a lookup in some block explorer for this transaction, because the trade fee of the other peer is not part of your, you're not getting notified about this transaction because it's not part of your wallet. So in Bitcoin J, you don't have default support for this. You could do it probably that you're requesting this transaction as well, or you make a lookup in external block explorer to see if the trade fee has really been published. To make the messaging a little bit more resilient, would be good to get a message received confirmation message. So every time when you're receiving an important message from the other peer, you're sending back a confirmation message. With that, like we had issues with the Tor network had issues with DOS attacks in December, January. And because of this, we also had quite a lot of issues because the network was less reliable and much slower. And then sometimes, especially the mailbox messages, sometimes the message don't arrive and there are issues. And with having the information, if a message has arrived, really has been confirmed by the peer, we could handle better such error cases like resending them the message or whatever, or knowing exactly where why the trade protocol has failed. Oops, sorry. Yeah, would be good to handle more error cases. I mean, it handles already the most relevant error cases, but from time to time there are some strange bugs, and then the trade protocol is stalled in a certain state, and sometimes it requires a little bit of extra manual work to fix then the UI, basically that the failed trade is not dangling in the table of the open trades. And I started in the beginning, I tried to handle all the errors, but it turned out to be a huge effort and was probably not worth to really handle all theoretical errors. But I implemented a small mini framework for doing this. It's basically, it's called debug view. So when you're in dev mode and with Alt-Z, you can open this debug view and you get combo boxes for selecting any task of any trade protocol, depending on which role you are. And then you can let fail the protocol at that task. So you can basically, at every step in the trade protocol, you can cause manually an error. And with that, you could test the whole UI and the whole protocol if it handles the error case at this moment correctly. I said it does not handle all the errors because it's a huge effort, but of course it would be nice to have here more resilience. I limited at the end to those error cases which really happens in reality and not only those which could happen theoretically, but in fact never happens. But that's for sure an area where we could improve the resilience of the application. And then to recover from error states. There are some error states which are not perfectly covered, as I said before. Sometimes there are happening bugs, and then offer is sticking around in the pending trades and not moved to the failed trades. And that's an open issue. And of course, to add more tests here especially integration tests would be good to really test bigger parts of the protocol, but also unit tests to have the smaller areas really tested well. And as I said before, a new feature would be this automated trading for altcoins. As soon as SegWit is implemented, we will, in BitcoinJ, we will have a look if there are some changes required for supporting SegWit. It's probably not directly in the trade protocol, only in the Bitcoin wallet. And with Lightning, that will be a completely different story. So once Lightning is really stable and mature, and once it's sufficiently supported from the BitcoinJ side, we would like to look into it, but probably that would lead to a completely new trade protocol and different application, because I think the changes will be very big here. Yeah, here are a list of some references, the two overview images, so the high level and the detail overview, and here is the package of the trade protocol in the code base. Yeah, I think we are more or less through everything. Are there any questions? I have not the YouTube channel open, so I don't see if there are live questions. I only have the Hangout.
I have it here, and no, there aren't any. Just a quick note for everybody watching now or in the future, those links that Manfred just shared and anything else in the slide deck, you can find a link to the slide deck in the show notes of this YouTube video. I think we just have a few watching live right now, so we might not have any more questions. Anything else from your side, Manfred?
Sorry, I was muted. Yeah, if there are no questions, I think we can close this topic. Of course, if any developer has questions, just ask on the Slack channel. And I think the next important topic to cover would be the Bitcoin part, maybe for next week. So Bitcoin J and the way how Bisq is integrated, is working with the Bitcoin layer. And if you're interested, and we are still 10 minutes or so, I could show a little bit the current state of the DAO that's completely non-related now to the trade protocol. Just would like to give a little bit of a live update of the current state that you get excited. If you're interested.
I would love to. Yeah.
Yeah. Then
Sure.
I will change my presentation to maybe to full screen because we have done some applications open. 1 second. Or no, I have it here already. Or 1 second, I go. No, it doesn't matter. Yeah, should be visible now. Here I have a developer instance of Bisq with the DAO enabled. And as you've seen, I tried out yesterday for a presentation today if everything works. I just show very quickly the overview of the UI and then make a full cycle of making a request, making the vote, and getting the issuance. The UI is still under heavy development and many parts are completely missing. So I'm not interested in feedback for the UI because I know myself way too much what need to be changed and improved. But and also on the code side, I'm not asking really for a review or for too much feedback at the moment because it's not really ready. It's still on the heavy development, and will require probably 1 or 2 weeks more until I'm kind of like ready for a review. You have here in the DAO menu, you have the 2 different or 3 different tabs: the wallet, the proposals, and the voting. The proposal and the voting will be probably just 1 tab. That's not clear yet. And in the wallet, you have a dashboard with an overview about your available balance, the unverified balance. So when you make a transaction, you don't know before the transaction is really in the blockchain if it's a valid BSQ transaction. So it will be then unverified, the balance which is spent from your transaction and which is not confirmed yet, and locked in voting. That will be when you do a voting, you are voting with your stake. This stake, as in the voting, we have 2 transaction: a blind vote transaction where your vote is encrypted, nobody can read it, and then a second transaction where you're revealing your vote at a later period. And this stake, which is used in the blind vote transaction, is locked in this time, so you cannot use this for making a normal transfer or whatever. And that will be also showed up here in the locked for voting, and they get unlocked then in the reveal transaction. We have here the information about the genesis block, the block number, the transaction ID, the total issued BSQ, 2.5 million. The available amount, that's the total available minus the burned fees. So I have here with my development environment, I've burned already quite a lot of fees. Then the number of BSQ transactions in total, the unspent outputs, all kind of. And when there would be some trades, then there would be the price. It's just taking the latest price of from the trade statistics on Bisq, and depending on this price, we could calculate the market capitalization. So when the price would be $1, it would be more or less $2.5 million. When you want to send BSQ, you taking the address from a receiver application. I can send here just to myself, for instance. I don't want to do it now because otherwise I need to wait for another confirmation, and then I put in the address. Note it's usually a normal Bitcoin address, so technically it's Bitcoin. It just contains a B at the beginning for Bisq or for BSQ to avoid mistakes that you're sending BSQ to a Bitcoin wallet. So when you would send to a normal Bitcoin wallet here in my funds, your BSQ, it's burned. So you would destroy your BSQ. To avoid such mistakes, we are using a special address with a B as a prefix. And here is the transaction list, where you see some information, which kind of transaction it was, the amount, the confirmations, and here the types. The Genesis transaction will also have a special icon, but this application, I just sent over money from another dev application. And here on the proposals, we have a dashboard with the different phases. I have here the phases just defined, also the phases are defined in blocks. In reality, the proposal phase will be something like 3 weeks, so there will be a few hundred blocks. For testing here, I just use very short blocks, so 2 blocks and then 1 block break. The break will be also something like minimum 10 blocks or maybe even 1 day. The breaks are required to avoid problems with reorgs. So when there is a reorganization of the Bitcoin blockchain, it could create problems when you have created on the last block a proposal, and then after the reorg, it's not, that there would be some tricky cases. And to avoid this, we have a break, and if any reorg happens, that should be covered by these breaks. Then we can create a proposal. We will see active proposals. We will see my votes. I've here done before a vote, so you see what I voted. And there will be more details, but that's not implemented yet. Then that's not implemented at all yet. The votes from the network, so what all the users are voting, which get published, the blind votes and revealed votes, and closed proposals are from the past, which are not in the active period. So this phase is also, the whole cycle of which is something around a month, which is similar like we are doing now on the spreadsheet. Every month we have a new issuance and the time for proposals and for voting. We have here this 3 weeks for proposals. Then the voting is here broken up in 2 phases. The blind voting, where you are doing your real voting, but nobody can read your vote data because it's encrypted. And then the reveal phase, where you don't need to do it manually. It's just you have to be online because your application is, as soon as it's entering this phase, it's creating this transaction where you're putting in the secret key for decrypting your blind vote and for revealing your vote, and a little bit more like this, and you're publishing this to the network. And then after another break, there is the issuance. That's just 1 block, and when the data gets verified, so at a Bisq application is either running as a full node where you have your local Bitcoin core node, and with RPC you're receiving every block and you are verifying every transaction, every block, if it is a BSQ, a valid BSQ transaction or not. And we are executing really every block on the blockchain there, beginning from the Genesis transaction, and that's why you don't have to be online here. It's done automatically. As soon as you go online, you are executing this special block, which is marked as the issuance block height, and block height. I always pronounce this wrong. And there you're basically, here the magic happens. Here you're printing money to yourself. So when your proposal get voted okay, you the output from the proposal transaction becomes an issuance transaction. You have created new BSQ. But yeah, let's see how it works in action. We have different proposal types, compensation request. Then there will be generic proposals where you can write any text. So it's not, it would require some manual effort from developers or whatever to implement it. Can be a request for support Lightning Network or whatever. And
Manfred?
Yeah.
Did you actually click that drop down? Because we can't see the
not I have not clicked it yet. Sorry, yeah, but strange that it doesn't. Maybe it doesn't show there. 1 second, I changed the. I think it's because it's another a pop-up is another window in JavaFX, and I made the application window visible in screen sharing, so it doesn't take this window. But it's not so important. I don't want to change to full screen because then you don't see so much.
Yeah, no problem. But maybe I'll just try to say, and you can correct me anywhere I'm incorrect here. We have this generic idea of a proposal, and probably by far the most common proposal type is going to be compensation requests.
Yeah,
That's what everybody files. Yeah. Currently, we do them every month. Maybe we'll change how often we do them, but the most common type is a compensation request, basically a proposal to pay myself X amount of BSQ for some valuable work that I've completed over a previous period. And that's what everybody's voting on. But other proposal types, and this is where it's like useful to have the generic top level idea of a proposal. It's like literally any change imaginable to Bisq or the Bisq DAO. Let's change how often we vote on compensation request proposals, right? Like it could get super meta. But like where you're talking about the issuance and so on a moment ago, that special moment, that's going to be probably only relevant to compensation request proposals, and everything else is just all about the voting process and getting enough votes to approve or disapprove whatever other kind of proposal there might be. So if you do, we have an enumeration of proposal types that you want to go through?
It's a little bit more. So this generic, for this, it's completely true, but there are two more, which I added just as kind of like example. Maybe we will not implement it fully for the first release, but we want to design it at least that we know that the DAO can handle it. So the basic idea is that over this voting process, we can change anything in the DAO. Of course, it has its practical limits because, some things will be really complicated to change automatically. That's why we have this generic proposal type, which will require usually dev effort to really make a new release and implement the changes. But there are some other really smart contract changes which can be done automatically, and then the issuance phase, which is used for the compensation requests to create new BSQ, that will then be used also to apply those changes. And maybe I go a little bit more into details of these other proposals. So one is for changing a parameter in the Bisq DAO, like the trading fee or the proposal fee or the quorum or the threshold. What you need as a quorum for any vote, you have a minimum amount of BSQ, otherwise it's ignored. So when there is a proposal and everybody is ignoring it and only one minor stakeholder with 500 BSQ is voting on it, it will not reach the quorum because the quorum will be maybe 5,000 BSQ, and it will, a completely minority stakeholder cannot do any change by himself. And the threshold is basically how much percentage you need to reach. So when you, at the moment, we have 50% for compensation requests. So as soon as you reach more than 50%, your proposal gets accepted or your compensation request gets accepted. But there might be different thresholds, especially for changing the parameter, because there's quorum and threshold are parameters itself and can be changed. So we don't want to easily let it change, because then people could, when somebody has enough BSQ and the other people are a little bit lazy and observing not very well, somebody could change then the quorum or the threshold to a very low level and would create damage, basically. So for the quorum and for the threshold, I consider a initial default value of 75%. So only when 75% of the voters will vote okay, it can be changed, this parameter. As well, the quorum will be higher, like 10,000 BSQ or even higher. And another proposal will be, and that will be executed automatically. So there's no manual work needed. Those are like for the trading fee, for instance, we are starting at the Genesis height. We are starting with the current trading fees. When the trading fees will be changed over time by voting, somebody makes a proposal, I want to change the trading fee to that and that number, and it gets accepted, then at the issuance at this block height of the issuance, we are applying the new value. So in the past, when we're executing the code, everything is dealing with the old trading fee, and at this moment on, we are using the new trading fee. So trading fee has no real effect in the DAO protocol, but for instance, the fees for the proposals are verified. So when the fee for the proposal change, a proposal might be invalid when it's in the wrong phase. So that's really important then to keep track of this, that at this height there is a new fee, and all the verification so is using then the new fee. And that's really that's a smart contract. There's no manual intervention. People are voting on this and changing some parameter in the DAO, and then the new parameter is valid and is used. And something similar, the parameters, we are using a long value there. I think we can cover all the data with long data type. Also, I want to avoid double data type. And but we also have binary votes, and the example for this is for removing an altcoin, as we have defined in our documentations about how to add an altcoin. An altcoin, we are basically adding any altcoin without applying politics, or we are not deciding if an altcoin is a scam coin or not. But if a stakeholder thinks an altcoin is a scam coin, he can make a proposal for removing an altcoin. And when it gets majority votes, it gets removed also automatically, not from the code, but in the display, in the what the users see in the altcoins, it will not show up anymore. So basically, we are delisting an altcoin. So that's also a way where we are delegating these decisions to the holders, and which gets executed automatically in code without any manual intervention. And the generic proposals are different. They are just, you can write any text and you can say, do that and that. And when it gets accepted, it's basically a strong signal to the developers that they should work on this and should implement this, but it's not executed. I mean, people can say, I would like to have support for Lightning next month. Yeah, that's nice. Everybody would like to have this, but it's not realistic and it will not happen because it takes probably half a year to implement this. So yeah. Let's go directly to the compensation request. It's the only one which is implemented yet. I have here pre-filled with dummy data, but of course that has to be filled out by yourself. The important is also description is just very short, and the importance is the link to a detailed, like the GitHub issue. And the requested amount, I have here 14,000, and my BSQ address that will be probably automatically filled with a new BSQ address from your wallet. Now I click Make Proposal. I get the confirmation screen, and now it's published. And now when it's not in the blockchain, that's why I don't see it yet. I create my rec test, I create a new block. So after this confirmation of the block, I will see here my proposal. As long we are in the proposal phase, so we are still here in the proposal phase, I can remove my proposal as well. Then it will be removed from the peer-to-peer network, and that's it. Technically, I create a Bitcoin transaction where I put in the op return a hash of the proposal data, and the proposal data will also contain the transaction ID. But of course, that's a chicken and egg problem. So the hash does not contain the transaction ID. So we create the hash of all the data excluding the transaction ID, put it into the blockchain, and then the transaction ID we put into this local data structure of the proposal, which gets published to the peer-to-peer network, and everybody can verify that there is a transaction. It's also a fee payment, so we see it here. The fee for the compensation request at the moment is just 1 BSQ. And we are verifying, also you only will see proposals which are correct and which have a transaction which is matching. Now we are creating another transaction. We are in the break, and in the next transaction we are in the voting phase. When we go here again, we see the screen has now changed. We cannot remove it anymore because it's already in another phase. But we can vote on it. We can accept or reject it. And let's accept this. So yeah, I could change it as long as I have not done my voting. When I would have several proposals, I would have it here in the list. I can, yeah, vote on every single proposal, and I can change it. It's only stored locally as long as I'm not creating really the vote transaction. So I can still change it. And once I'm sure I want to publish my vote, the collection of all those proposals and my votes on those proposals get published, and I can define how much stake I want to use for my voting. Let's say I would use maybe 200 BSQ. And when I click here, we don't see any confirmation yet, but we see here that a transaction has been published. It's still unverified because it's not in the blockchain. We don't know which type of transaction it is. And we see it also here. Yeah, I voted with some BSQ, and I used some input, and that's the change output. So that's unverified still. When I create a new block, everything gets resolved. We see it here, 200 BSQ are locked in voting. We see here this transaction, that's the fee for the blind vote, 2 BSQ. And yeah, and in the phase, we have to wait now for the reveal. Also, in this moment, everybody receives those blind votes, which are encrypted data. You cannot read anything out of this. The only thing what you see is the stake. But with that, you don't know much. That this blind voting is important because earlier we didn't have this. We voted, yeah, it was clear voting. And with that, we had this problem that there was an incentive to wait until the last moment because you have more information, and there was some attack scenarios where you could try to make a lot of influence in the last moment, and then the other are too late to see your changes. And with that, we don't have this anymore because nobody knows what people have voted on. And in the blind voting, technically in the op return, there is your list of proposals with the votings, which is encrypted. That's the data in the blind voting. And we are, yeah, and the blind vote is also a peer-to-peer message, which gets sent to the network, which contains then the ID of the blind vote data. I'm not 100% sure if there is a hash also in the op return, but I don't think so. We are creating new blocks again, and now we are in the reveal phase, and you don't need to do anything. You only have to be online. As a voter, you have to be at least once online in the reveal phase. So the reveal phase will also be something like 2 or 3 days. So the voters have a little bit of time. And as soon as it's online, the application will create this reveal transaction. We see it, it's not confirmed yet. Now it's confirmed. And the reveal transaction will contain the secret key. So everybody can decrypt their blind vote, and will contain a hash of the list of all your blind votes. I will explain this a little bit later because that's a little bit tricky. But that's something important what we also need to consider. And yeah, we are going to the next break, and we are going to the issuance. And we see here it has not changed. Before it was a fee for compensation request. Now this transaction is a issuance transaction. It's this compensation request transaction, which happened in the past, has one output for the issuance. This output is Bitcoin at the beginning, and only at this issuance moment, when all the votes are calculated, and it's clear that this proposal has been accepted, this output becomes a BSQ output. It's basically, you are doing the same like a Genesis transaction. You're creating just a normal Bitcoin transaction with Bitcoin input, and and in the Genesis transaction, I define basically that this is now BSQ, and here with the issuance by voting, by being successfully accepted in the voting process, the network has defined that this is now valid BSQ. But technically, the input was Bitcoin. You have created BSQ out of Bitcoin. And of course, the Bitcoin, what you need to put in is it's just a few thousand Satoshi, so that's very little money. The BSQ will have a high value, so you have created real money then. We have, I mean, here we see the 14,000 minus the 1 BSQ for the compensation request fee. Maybe I will change this in the UI to make it a little bit more clear and have it 2 entries, or show this in a better detail. But because this transaction, no, I think that's just a glitch in the UI that the balance has not updated. That happens with the next confirmation. Now, we see it also in the balance. Before we had around 1,000 or 999, 97 or whatever BSQ, and now we have nearly 15,000 BSQ. Also, we really have added up the 1,000 what we got initially plus the 14,000 minus the fees. And I explain a little bit more this detail with the hash of the voting. So it could be that when every peer is creating the result of all the votes, and it could be because this data is published in a peer-to-peer network, and the peer-to-peer network has eventually consistency. It could be that some people don't see all the votes, and then they would calculate a different result. For instance, there have been 10 voters, and I only have received 9 votes. And maybe that missing vote was essential if a compensation request was accepted or rejected. So I will get a different result like all the other 9. So it would be a conflict. To avoid this, we are using the voters themselves in this second phase, in this reveal. They have received from the network all these blind votes. And they will make a sorted list of all the blind votes, what they have received, make a hash of this, and put the hash in the op return. The Bitcoin block data is available for everybody. There is actually a consistency problem there. So when I, as a normal user, will be in the issuance phase and calculate everything, I will first I will check if the hash of the blind votes which I have received is matching to the majority of the voters, of the hash of the voters. So when there are 10 voters, and for instance, one of the 10 voters have only received 9 blind votes and all the others have received 10, the one has a different hash like all the 9 others, then the majority, we use the stake for the majority. It's not the number of voters, it's the stake. And probably this single one who has a different hash will be the loser, so his data view is invalid. And then we are, so those 10 blind votes are the one which will be taken for calculating the total result. And when I, as a user, has only 9 and I'm not on the majority data view, I have to request the missing data from the other peers. And I have to resolve basically my data view conflict. And as long as the majority, they're basic, I mean, I don't want to get lost in too much details here. With that mechanism, we ensure basically that everybody has the same data view, which is used for calculating the total result. The total result, you're just summing up the accepted and the declined vote by the stake. And when you reach the quorum and the threshold, it gets accepted. Otherwise, it's rejected. And of course, it's doing all the verifications with if the vote, if the transaction have been in the right phases and everything, and if everything matched together between the peer-to-peer network data and the transactions. And that's it basically. Also from the domain side, it's already pretty good, in a good state. Still require more refactorings and more tests and more checks. So I'm not sure if it works for more complex cases. Like I've tested a little bit with when two applications are voting and one is rejecting, one is accepting. That works also correctly, but it's not tested well. So there's for sure much more work. left on the UI. There is a lot of work open, but basically it's already in a pretty good state, and hope more or less in 1 month it might be kind of like ready for testing. And I would like to use it then as soon as it's in a good shape to use it on testnet for replacing our spreadsheet. So we have a kind of like a real life test where still when there are bugs or so, nothing terrible goes wrong because it's just testnet. And maybe after 1 month or 2 months, when we are sure that everything is fine, we will go down on mainnet and launch it.
Yeah, I think what we can do is essentially propose and vote in parallel, probably for a couple months, right? Use the existing phase 0 infrastructure, the spreadsheet, etc. Walk through that like we usually do, and then like repeat the process in the app, and we should get consistent results out of both systems, right?
Yeah,
might be a way to go.
Yeah, that's a good idea also to have when something goes wrong that the data are not kind of like lost and we have to repeat the voting. It's still then in parallel in the spreadsheet. Yeah, and
that's great. Thanks for the sneak preview. It's really exciting.
Yeah, I'm also, I mean, of course, it's very kind of like we're playing with fire. When anything goes wrong, it's really dangerous. We're printing money, and when there are some bugs, it can be a disaster. So we have to be super careful and test it. Yeah, it will be the most critical area in the application at the end, because with a trade, it's just limited damage for this trade amount. What can we have the arbitration, and we have a lot of fallbacks here when there is a huge bug where people could print out money out of thin air. We have some firewalls like limits what you can issue, and we can confiscate and whatever. So there are some mechanisms in place already when we launch to limit the possible damage. But yeah, we don't want to get to the situation, of course. So we have to be super careful and test really well everything, and would enjoy to get some additional help at a certain point, but at the moment it's still not still too much prototype level.
Cool.
Goodie.
Anything else before we get out of here?
From my side, I think not.
Okay. All right. Well, stay tuned for next week's tech session. We'll talk all things Bitcoin inside of Bisq. And until then, thanks everybody.
Okay. Thank you. Bye-bye.